Let's look at how we can use Excel to test the significance of R. Now, this is a little bit more complicated than a lookup table, but we get an exact p-value for it, which is how we report p-values in most modern contexts. When you use just a significant, the table of critical values, we just have to report p less than 0.05, which is fine. But if we use Excel or other statistics software, we can use the exact p-value that we have. Now, what we're going to do here is we're going to use some data that we have and see if we're going to test the significance of the correlation between two variables. In our example, we're going to use Justin Bieber and age, and we're going to use regression and data analysis to obtain the correlation and the p-values. So what we're going to do is we're going to download the data set. We're going to do the regression analysis. And then we're going to look at the parts of the regression analysis because we're going to get not thousands, but over a dozen numbers and see which ones are important for testing the significance of R. So let's find the correlate. Okay, here is our data, and we are going to do a let's say test the significance of the correlation between age and Bieber. Remember, Bieber, that variable is how much people liked Justin Bieber on the scale of 0 to or 1 to 5. So we're going to go to data analysis, and you should have the Data Analysis Toolpak installed. If not, see the video on that. I'm going to click Data Analysis, and I'm going to go to regression, just like we saw for multiple regression, but here we're just going to do two variables. We're not going to have multiple variables. And the Y input range is going to be, it doesn't matter what the X and the Y is here. So let's put Justin Bieber as our Y variable. See if age predicts Justin Bieber. Okay, so that's our Y variable. I highlighted that, including the header there. Now I'm going to click on age, our X variable, and highlight that. And there now we have the two variables there. I have the labels in the Y and X range. That means the age and the word Bieber and the word age in the first row. Now we want the output range. Now I want it on the same sheet, so I'm going to click there. Now remember, there's a little weird thing. The cursor goes up there. We want to put the cursor here, and I'm going to choose J3, and I press OK, and we get tons of data coming out here. And one of the things that we can do to make this simpler is reduce the decimal points. Go to Home, General, put the number, and that'll reduce everything to 2 decimal points. Now we can add decimal points with this function if we need more. Now let's make these wider so we could see what's going on. Those are the, let's make it a little bit bigger so we can read some of these. Okay. Now, the variables that we especially need, we've got quite a few here, are the multiple R. That is the same thing as small r, or the absolute value of small r, when you have just two variables in the regression level. So I'm going to label this as, this is the absolute value of R. So it doesn't tell us the sign, it just tells us how strong the R is. Here is the actual significance of R. This is the p-value of R, and if it's less than 5%, we say it's significant. So I'm going to say P, whoops, let's make this red so it stands out. P value of R. Now, so this is a two-tailed or non-directional test. If we had a one-tailed test, we would divide that by 2. So here we say p equals 0.02, or if we wanted to be more precise, we could highlight that one cell and add an extra decimal point, so p equals 0.022. So that's an important value. This is the degrees of freedom that we always have to report in a PA format. So it's important to note the degrees of freedom. And then for the sign of R, we need to look for the sign of the coefficient. So this is the sign of R there. It's not the actual value of R equals 0.46, but the coefficient, if we are making the regression equation, gives us the sign of R. So let's summarize what we have. We have, let's see, I will put R equals minus 0.46, because we had the 46 up here, the minus sign is there. What else do we have? We have the degrees of freedom equals 23. We need to report that. And so that's the degrees of freedom in this middle section here. And then our p-value, control I, P, control I off, space equals space 0.02 or 0.022. There's no specific rule there on what you have to report. So that's how we can test the significance of R, and we can conclude, therefore, the correlation is significant because P is less than 0.05. All right, let's go back to, so here we've got the output. Now, how do we report the these correlations in APA format? Our hypothesis will be there'll be a correlation between liking Justin Bieber and age, and this correlation we just tested it. This is one that we just tested. But the way that we can report this is that the Pearson correlation between liking Justin Bieber and age. Now here we report the sample size, n equals 25, was significant. And we can put, the way that we write this in APA is we can put a comma, and then we report our R statistic, which is in italics, and we always put the degrees of freedom right after it. So R, and then non-italics, we have parentheses 23, space equals space minus 0.46, and then comma, and then our p-value is in italics, and we have spaces before and after the equal sign, because it's just like a word, 0.02, and then a period at the end of the sentence. So that's how we report our results in APA format. Now, if we had made a one-tailed hypothesis, the correlation between liking Justin Bieber and age will be negative, which we might have been able to guess. We would need to divide the p-value by 2, so we would have reported p equals 0.01.